is section 1.4. If you look at it, is the introduction to all the information from chapters 4, 5, 6, and 7. So that's half of our book. And so there's a lot of information in here. Much of it is review, hopefully, but I still want to make sure that I go through it and make sure you're exposed to the things. All right, so the section 1.4 introduces closed figures. Okay? So closed figure is anything that is contained by a boundary, and that's the definition for a figure. I'll try to be specific with that. So I'll try not to refer to the term figure as being something that's not completely enclosed, although often you'll hear or you'll see in books that says in the figure at left, what is, whatever, and when it's describing an illustration. I'll try to use the word illustration if it's not a figure itself. But a figure is something that is completely enclosed, and the enclosure itself is referred to as a boundary. And so a figure can be bound by either curved or straight lines. We're not going to make that distinction yet, and that's going to come to something as we get started. Historically speaking, figures or straight and curved lines weren't distinguished. What made a line historically was the ability to take any portion of that line or element and place it anywhere else on the element and for it to map on perfectly. That was how it was defined as a line. And for the most part, in this class and kind of the current thoughts, if you hear line, you usually think of it as a straight line. But I'll kind of let you know when that occurs. So right now, a line is not necessarily going to be straight until we get to a little bit later in this section. Okay. All right, the figures themselves are kind of introduced in the order that they're going to appear in the text as well. And I did that, or I modeled that after the original Euclid's Elements, the original recorded study of geometry. And the first element that was, or the first figure that was introduced there is a circle. So a circle historically was said to be contained by a single line, by one line. Now, what that meant was you can take any portion of a circle, cut it off, and you can remove it, and you could place it anywhere else on the circle, and would it map directly onto that? Yeah, so that was kind of where the definition of line came from. So a circle is the figure that can be enclosed by one single line. It happens to be a curved line, but it's that one line. When we look at the definition for circle, the definition that I have written here, I wanted to point out to you, is missing one little part. If I were to say a circle is defined as the set of points a given distance from a fixed point, actually that definition would include, so if my fist were the given or the fixed point, and let's say my other fist here represented that given distance, if I were talking about the set of all points that were this same distance from this fixed point, what am I really talking about? It's a sphere, right? It's 3 dimensions on that. We want to limit our definition of circle to 2 dimensions. Any ideas on what we could insert in this blank spot to limit our definition to just the 2 dimensions? The points have to be where? In coplanar. They have to be in the same plane. So if we add the term coplanar here, we get the circle is by definition the set of all coplanar points that are a given distance from a fixed point. The fixed point is called the center, and the given distance is called the radius. And so when you're looking at a circle, a couple other things that we can identify about a circle. Circle is an enclosed figure. Contained by a single line. and I'm going to include in the historical sense. Okay? Again, that where the line doesn't have to be straight. Okay, the boundary of a circle is called its circumference. Okay, the boundary of any figure is its perimeter, so the circumference is just the distance around the perimeter of the circle. Okay, the circumference is just the specific name given to the perimeter of a circle. As I mentioned, based on the definition, the fixed point from which a circle is defined is the center, and the distance, the given distance from that fixed point is the radius. And when you identify radius, a radius is identified, so let's say we put point A here on the circle. The radius is identified as a segment. And so the radius of this circle is a segment AC. A center is located or identified as just a point. So the center of this circle is point C. And when you're naming or denoting a circle, you have two options. You can either name it based on its center point. And so that notation would just be a circle with a dot in the middle and then the center itself, the point that represents the center. But just like an arrow, or I'm sorry, just like an angle, if the center of a circle is the center of more than one circles, you can't name it as a single point. So if I put a second circle here, and this is you're no longer able to identify this as circle C, because now there's two different ones, a larger and a smaller one, and so you have to name it using a different method. And so the different method for naming a circle would be to choose 3 points that lie on its circumference. And so if we had points A, B, and let's say D here, this could be named circle C. It can also be named circle ABD, or any order. It can, again, the arrangement can be clockwise or counterclockwise. It really doesn't matter because you take any 3 points in any order, and you can name the circle that way. So with respect to the circles, there's another concept to keep in mind, and if you look at the slides, you guys should be familiar with diameters, but this illustrates some more. What is the kind of defining characteristic of a diameter of a circle? It has to do what? Claire? Perfect. So again, hopefully you're familiar with diameters, but a diameter has to have a segment whose endpoints lie on the circle, and it also has to pass through the center of the circle. So you see that in these illustrations. And so a diameter is going to have going to be a segment whose endpoints lie on the circle. Okay, what is that called? What is a segment whose endpoints lie on a circle called? You guys remember? So a tangent's going to intersect the circle at just one point. We'll talk more about that in chapter 4. There's another word. So it's a segment whose endpoints lie on the circle. Matt? Did you mouth that? I thought it. Yep, chord. Okay, so diameter is just a chord that passes through the center of a circle. So it's a segment whose endpoints lie on the circle. Oops. That also passes through the center. Okay, so the other thing that a diameter happens to do is a diameter can take a circle and cut it into 2 halves. And each of these halves is called a semicircle. Okay, so a semicircle can be defined in a couple different ways. Just kind of one way to think of it is half of a circle. Okay, but this doesn't really give much in terms of the description of it. And so when you're trying to define a semicircle, it winds up being defined. So the circle is a planar figure that's contained by one single line. A semicircle is going to be contained by two lines. Okay, again, in the historical sense. It's going to be contained by, it's the portion of a circle that's cut off by let me reword this. It's a portion of a circle that's enclosed by the diameter. And the circumference cut off by that diameter. Okay, so if you took a circle and you drew in your diameter and the portion of the circle's circumference that's cut off by that diameter, you have your semicircle. Okay, so a semicircle can still have a radius, can still have a diameter, which is designated with a D. It can still have a perimeter. The perimeter is going to be the diameter plus half of what the circumference of the circle would be. We'll talk more about that later. Give me a second. It'll either reconnect or it'll allow me to resend it. All right. All right, so a semicircle is considered to be the planar figure enclosed by two lines. Again, in the historical sense. Okay, two lines meaning that one line is the diameter. It's a straight line. Again, any portion of that diameter can be removed and placed on any other portion of it, and it'll map on perfectly. So it's considered a line. And then same with the curved portion. You can cut off any portion of the curved part of that semicircle, remove it, place it on top of any other portion of the circle or of that curved portion, and it would map on it directly. So that's kind of the historical sense of the lines. Okay? So circle is formed by one line, semicircle formed by two. And so that concept of how many lines it takes to enclose a space is how I ordered this book. So circles are first, and then semicircles are kind of contained in that, and then that's chapter 4. Chapter 5 will be triangles, 3, a figure enclosed by 3 sides, and then quadrilaterals are next, 4 sides, and then all the others are after that.
So I don't understand how the figure is enclosed by 2 lines.
So as far as the historical sense of the word line was, it was defined as an element that you could remove any part of it, take it off of the element itself, place it anywhere else on every other part of that element, and it would map on perfectly. So in a circle, if you took any chunk of a circle, no matter how big or small, you removed it, could you place it anywhere else on the circle and it would map on perfectly? Yeah, so that's why the curved line of a circle was considered a line. Now the other thing so straight lines are the same, right? If you took a straight segment or straight part of a line, removed it, could you place it anywhere else on the line and it would map on perfectly? Yeah. What about something like this? If you took this curve, if you removed this part of the curve, will that part be able to map on in every other part of this curve? No, it's not going to. It would have to be like right on that exact part. Now, what about, there's the one other thing that actually was considered a line back then was kind of like a spring. You know how a spring coils around? Like, could you take any part of a spring, remove it, and place it on any other part of that spring and have it map directly onto it? Yeah, so that would be, like, that's technically the other kind of historically defined line. But, like, with a spring, you don't, it doesn't enclose a space. It just continues to spiral. But in the historical sense, circle and semicircles are contained by lines. And now,